right, so if you can turn to page 24 in your Unit 2 packet, today we're going to talk about really graphing polynomial functions. So we're going to start off on number 38. Okay, now the first thing it says is find algebraically the zeros of p of x. Okay, so if we know, we want to find the zeros, we just set our function equal to 0. So why don't you all hit pause, solve this, and when you're done, you could hit play and see how you did. Okay, so the first thing you should have done was grouping, right? So when we group, out of these first two terms, you pull out an x squared, and out of the next two terms, you pulled out a minus 4. Now, since both of our parentheses say the same thing, let's continue on with the grouping process. Now, I'm hoping when you did so, you realized that this right here was dots, so this could have been factored further. Okay, so when we factor this further, that factors to x plus 2 times x minus 2, in whichever order you want. Now, they had asked us to find the zeros, plus we have an equation set equal to 0, right? Make sure you have this equal 0 the whole way through. So when we solve, when we set each of these factors equal to 0 and solve, we wind up with 3 solutions. X equals negative 2, positive 2, and negative 1. I also put them in curly brackets here, so if you prefer to do that, right, you could put your answer like that. Instead, it's totally up to you. Okay, so we have a third degree function, which means we could have a maximum of 3 zeros, and we wound up with 3 zeros. Okay, now it says on the set of axes below, graph y equals p of x. So this is where we're going to get into actually graphing the functions. All right, so what I'd like you to do is if everyone can take out their calculator and go to y equals, and under y1, I'd like you to type this in. Okay, so go to y equals, right over here. I actually typed mine in already. And you can graph and look at the graph if you want. But whenever you graph something, right, I like to look at the table of values because that tells me what points we want to plot. So you're going to hit the second button right here and then graph, second graph. And that'll give you the table of values. And you want to plot any values that fit on that set of axes. Okay, so you may have to scroll up or scroll down depending on where your table of values is, but it looks like to me that this set of axes goes from negative 10 to positive 10 along the x and y axis. So, looks like I could fit, let's see, everything from negative 3, negative 10 up until really 2, 0. Because once I get to this, 3, 20, 20 is too big. It's going to be off the graph. Okay, so let's plot those points. Okay, so I went through and plotted them. Negative 3, negative 10 means go back 3 and down 10 and put a point. Negative 2, 0 means go back 2 and up 0 and put a point. Negative 1, 0, you go back 1 and up 0 and put a point. Okay, 0, negative 4 means you go 0 units along the x-axis so we don't move over, but we go 4 units down on the y-axis. So we're going to go over 0, down 4. This would be over 1, down 6. So over 1, down 6. And then this would be over 2, and we don't go up or down, okay? So over 2 and up or down 0. All right, so now you can connect these. And when you do, notice that 3 is all the way up at 20. So when you go to 3, right, make sure that your graph doesn't hit any of these points. So when you connect these, right, like this, make sure this comes straight up and you're not going to cross over this x value of 3, right? Your graph isn't going to come like off to the side. Okay, so connect those, and when you do, your graph should look something like this. Now, so notice that, I mean, technically if you graph to the end of the axis, you don't even need these arrows. If you go all the way to the end of the axis, it's implied the graph keeps going, but I'm a fan of putting arrows anyway. And notice I labeled it p of x. If you want to write the whole thing, you can, but when you write something in function notation, right, p of x instead of y equals, you can just label it p of x. Okay, and the last thing they want us to do is describe the end behavior. So I'd like you to hit pause, see if you could write out the end behavior wherever you have room, and then hit play and see how you did. Okay, so I decided to label what was what because they asked a lot. So these were my zeros from before, and then my end behavior. So as x approaches negative infinity, which means as we go to the left, isn't our graph going down? So notice I said p of x approaches negative infinity, not f of x, not y. If this function is p of x, please make sure you write p of x. Okay, and then as x approaches positive infinity, so as we go to the right, isn't p of x going up to infinity? So p of x approaches infinity. Okay, so now let's take a look at the next one, number 39. Okay, so Patricia creates a cubic polynomial function. So cubic, remember, is third degree. P of x with the leading coefficient of 1. The zeros of the function are 2, 3, and negative 6. Okay, now the first thing they want us to do before we graph is write an equation for p of x. Okay, so everyone hit pause, take a look at what they give us, and see if you can write an equation for p of x. Okay, so this is what I wound up with. How'd you do? Right, the leading coefficient is 1, so I put that in front. And then notice I wrote p of x equals. Okay, you want to label your function. Now, if our zeros are at 2, 3, and negative 6, our factors would have the opposite sign. So the factors would be x minus 2, x minus 3, and x plus 6. Now, some of you may be tempted to distribute, right, and multiply this all out and write it in standard form. I recommend you do not do that. If it just says write an equation for p of x, I would leave it in what we call factored form, because that way you don't take the chance of making a mistake while distributing this all out. Okay, so sometimes less is actually more, right? Okay, now the next part says to sketch y equals p of x on the set of axes below. So take a look at what we know, right? The factors, the zeros, it's a cubic. We have a leading coefficient of positive 1. And see if you can sketch a graph of this. And by the way, a sketch does not mean you have to have accurate points like we did in number 38. It means you just sketch the important points, so like your intercepts. In this case, we should know our x-intercepts. And then you want to have, the general direction and shape of the graph. So hit pause and give it a try. And then when you're done, you can hit play. Okay, so this is what mine looks like. I knew we had zeros at 2, 3, and negative 6. So at 2, 3, and negative 6, I put points. And notice, I put these numbers on the x-axis. A sketch, you still have to include where this happens. Please don't just, do one of these. Don't just be like, oh, there's 6, there's 2, there's 3. Okay, you have to actually put the numbers there. Okay, they need to be there. And I like to actually put the tally marks like that so that they're spaced appropriately. Okay, so we knew that the leading coefficient is 1. So since it's positive, we know the right side of our graph is going to be going up. So if this is going to be going up, and it has to go through these 3 zeros, right? And it's a cubic. This is what the shape of a cubic looks like. I knew that, this had to be going up, and it had to go through positive 3, positive 2, and I figured it had to go up a little higher here to get all the way back down by negative 6, and that is what my graph looked like. Okay, put arrows. Arrows are needed. And to show it keeps going, and I also labeled it p of x, so your graph should look something like that. Okay, I'd like you to try the 2 examples on the next page, number 40 and 41 on your own, and once you finish them, then hit play and see how you did. All right, so this is what my graph looks like in number 40. So you could see here that it's a cubic. Okay, we know cubic looks like this, like you see here, or it could also have gone this way, right? But it says here that we have zeros at negative 3, positive 2, and 5. So notice I labeled exactly where those were on the x-axis, but there was a relative maximum at negative 1, 9. So in order for it to go through this point, right, even though they don't tell us that the leading coefficient is positive, in order for it to go through these 3 zeros and this maximum, the graph must come up from negative 3, hit this point, and then come back down through positive 2. So the graph could really, if it's going to go through these 3 points as well as this relative max, right, a maximum, the only way it's going to do that is if it comes up through negative 3, hits that maximum, comes back down through positive 2, and back up through 5. Now, I did put arrows. If you notice, I did not label my function because I don't know if it's f of x, g of x, h of x, whatever it is. That's okay. They didn't tell me. I do not have to label. So this is what I have for number 40. Okay, so now as far as number 41 goes, there's two different ways you could draw this one out. So either one of these is fine as long as you had one of these. Now, it says that P of X has zeros at -5, 1, and 4. So at -5, at 1, and at 4, I put zeros. It also says that as we look to the right, the graph goes down. And as we look to the left, the graph goes down. So basically, the graph is going to have to end up coming down on the left and on the right. Okay, so let's think about this. If it's going to come down here, right? If I came up, down, ooh, that would leave me going up. So what that must mean is there's multiplicity. Okay, now they don't say where there's multiplicity, but let's think about this. Okay, so this is going to be down and this is going to be down. I guess from here the graph could go up. I guess it could come down and bounce off at 1 and come back up and come through 4. That would be one possibility. So let's draw that out. Okay, that's our first possibility. So it could come up here. It could start coming down and bounce at +1 and come back through at 4. So here's, if you drew this for P of X, this one works. The other way it could do it is, let's think about it. If we came up through -5, came down through 1, couldn't it bounce right here as well at +4? Okay, so the second option for this graph would be like this. And have it bounce at +4. Okay, now notice I put arrows on both of these. I labeled both of them P of X. And when I put my arrow, see how this graph continues down? Please don't make your graph come over like this. Okay, sometimes I see people, I'm going to do this in green. Sometimes I see people go like this. Okay, this you would get marked off for because this implies that the graph is going to come over and work its way back up again, okay? The green is no good. We don't want that. We want it to wind up just coming down. Okay, so green, erase that, get rid of that. The green is no good. All right, so these are the last two that we're going to take a look at for today, number 42 and 43. And 42, you could see, they give us P of X again, right? They keep using that function. And this time, instead of giving us numerical values, it's saying X minus A, X minus B, X plus C. And they also tell us that we have a positive y-intercept of D. So what I'd like you to do is read this question carefully, right? Read all the details and see if you can sketch a graph of this. So hit pause and try it out. Okay, so we know that if we have a factor of X minus A, doesn't the 0 have to be at X equals positive A? Okay, so somewhere on the positive portion of the x-axis, let's put A. Okay, then if we have a factor at X minus B, doesn't that mean that we have a factor somewhere at positive B? Now, let's think about what I did, because I know you've read further, right? You've already done this. If you keep reading, it says that A is greater than B. Based on where I put my A and B, does it appear that A is greater than B? No, it doesn't, right? All right, so let me erase where I put B. I need to put that somewhere on the positive portion of the x-axis, but to the left of A. So I'll put my B right here. Okay, and then going back to our factors, if we have a factor of X plus C, doesn't that mean we have a 0 at X equals negative C? So I'll put my negative C here. And make sure you put the negative in front of it because it's on the negative portion of the x-axis. Okay, and we also have a positive y-intercept of D. So here's our y-axis. So somewhere on the positive portion of the y-axis, let's put D. Okay, I'll put it right there. Okay, so then basically all we have to do is we just have to connect these. So if it's going to come, it's going to these x-intercepts, and it's going to come through the y-axis at D. In order to do that, it must come up to positive D and then down and back up. Now, I know there's no multiplicity because isn't x times x times x, x to the third, right? X to the third, which would be a cubic. And if I come up, down, and back up, wouldn't that be a cubic? Okay, so Ready? Critique my graph. How does mine look? All right, so it's going to come up, come back down, and then it's going to go up, and I'll go like that. How does that look? No good, right? We talked about this last time. This should not go over. If it comes up through A, it should continue to come up. So let me erase that. I would definitely lose points for that. That is not what my graph is going to look like, right? A cubic would continue to come right back up like that. And I can label this P of X. Okay, the very last one you're going to do today, I'm going to have you hit pause and try it, is this one. They give us an equation, and they say to do it over this domain. So it means these are the X values that we are going to include. So I'd like you to go to Y equals in your calculator and plug this in. And then when you go to the table of values, right, where we have the X and the Y, you're only going to include the X values. And see how these are underlined? That means we want to include -1 and +4. So you're only going to include the X values that go from -1 all the way up until +4. Okay, so take out your calculator, try this out, and when you're done trying it on your own, then you can hit play and check how you did. Okay, so I took pictures. In my calculator, I went to Y equals, and I typed in this function, although look, my cursor is blocking the X, but it's there. And then I hit second graph to get my table of values. And keep in mind, we only want to plot the ones between -1 on the domain from when X equals -1 up until when X equals +4. Okay, so these are the corresponding Y values. So if you didn't do so already, let's plot those. Okay, so my graph, it came out a little sloppy on this, but my graph actually has 2 mistakes. Okay, so look at it closely, think about it, and what do you think my 2 mistakes are? Okay, so the first one, yes, if you said I forgot to label, you're right. I forgot to label it, so let me label that right here. F of X. And you can write the whole thing if you want. Now my second mistake, you may not have picked up on this, but let me get this out of my way. Okay, see right here where it says to graph on the domain from -1 to +4? What that means is start here at -1, stop here at +4, and do not graph outside of that. So if we're not going to graph outside that given domain, what that means is, see this? These arrows should not be here. It means start here, right? Stop here, and do not go outside that given domain. Okay, so I would like you to write this here. Do not graph outside this interval. No arrows, okay? When they give you a domain to use, it means start here, stop here, and that's it. So this is really what your graph should look like, okay? And I took a picture of my paper. It's always a lot easier writing on paper, so I figured that came out a little neater, but that is what your graph should look like.